Good day, everyone. Welcome back to Harvard News Program. I am Wendy, your broadcaster of this session. The first topic we want to discuss is one of the hottest topics among the public. The government has taken steps to rectify this situation. In recent weeks, approximately 5 rivers in our country have become polluted by palm oil mill effluent, (POME), a well-known byproduct of palm oil production. Those polluted rivers are near the palm oil factory. The government has created a research team to find a solution to reduce the pollution rate caused by effluent. Their objective is to minimize the risk of river water pollution through advanced and innovative treatment processes. And today, the team has come up with a solution. They suggest implementing electrocoagulation to treat the POME. They assert that the electrocoagulation method is cost-effective, user-friendly, and results in less sludge production. Let us learn more about the treatment process by watching the video produced by the team.
Are you curious about what is the electrocoagulation process? Perhaps with the progress and does it is workable or not? We believe you all do. The purpose of this video is to explain what it is and why we choose it to improve the treatment process in the palm oil industry. First of all, electrolysis is a broad-spectrum treatment technology that can remove the total suspended solids, heavy metals, emulsified oils, bacteria, and other contaminants from water while at the same time, it is working to remove all these contaminants from palm oil mill effluent, which we will mention as POME for later. It operates by conducting a direct current to the cell, and the electrode metal species will then generate metal ions. Electrochemical cells are then hydrolyzed and generate ions according to the respective reactions. There are 2 electrodes to conduct the process. We use the iron electrode to improve the results. Water molecules are attracted to the cathode, while ferrum ions will be attracted to the anode. Ferrum ions will further react with the dissolved oxygen. Do you know what is inside the POME that caused the water pollution? Here are the parameters that cause the river water to turn brownish. The details of each parameter are shown here, with their concentration measured in milligrams per liter, except for the pH value. There are 4 aspects to conducting the electrocoagulation process. By referring to the experimental scale, supplying 80 mA per centimeter square current density to the cell has the best results. Next, an iron electrode is chosen as it is more feasible and provides better removal efficiency of POME. Stirrer is used to avoid the association of flux during the electrocoagulation process. Oxidizing agent, which is the hydrogen peroxide, and an additional coagulant, polyaluminium chloride is added into the process to increase the removal efficiency and provide a more significant result. All the data are taken from the experimental result. Now, we will explain how electrocoagulation works. In the electrocoagulation cell, the iron, ion is driven into palm oil mill effluent, POME, at the surface of the anode. At the same time, water is hydrolyzed at the cathode after the power supply is on. Hydrogen peroxide is added as an oxidizing agent to oxidize organic pollutants. Electrons move freely from cathode to anode, destabilizes surface charge on suspension solid and emulsified oil. At the same time, the added polyaluminium chloride acts as a coagulant aid and destabilizes the pollution materials and aggregates them. It has a large surface area to trap colloidal particles and absorbs soluble organic compounds. Metal complex is formed by iron, ions and hydroxide ions. Large flocks formed when the destabilized pollution materials mixed with the metal complex. Hydrogen gas formed as bubbles at the cathode due to the reduction lift of the flocks from the POME. Thus, the flocks that consist of pollution materials were removed from the POME. Besides, we can achieve higher COD removal efficiency as the settling ability has increased with the aid of polyaluminium chloride and hydrogen peroxide. The electrocoagulation was carried out for more than 8 hours, which include the time consumed for the replacement of the electrodes. The electrocoagulation reaction is further accelerated in the settling tank to remove the remaining pollution materials in POME. The POME flowed continuously in the tank, and most of the pollution materials in the POME settled down. In the filtration system, the POME flows down the tank through a media bed that traps the remaining particles. Thus, the clear filtrate exists at the bottom of the tank. At the end of the process, most of the pollutants and 95% of COD are removed. There are several benefits of applying electrocoagulation. It requires less retention time, produces less sludge, and consists of simple equipment that is easy to operate. Besides, the maintenance cost for this implementation is low and cheap. Last but not least, there is no addition or less amount of chemicals in the reaction. We aim to produce great beauty things. Love yourself and you're the world. Thank you.
After few years, we succeed in having the more clean and clear rivers with implement of palm oil mill effluent treatment process.